Hello students, this is the lecture based on the chapter microbiology, and this is a part of the microbiology chapter which is called the microscopy. And if you divide the chapter in three parts, then you can take it as a second part of the chapter. So now it is no accident that the development of microscopy and microbiology have often been closely interlinked. Microbiology begins where the naked eye reaches its limit. Okay, so this is the scientist. I think you know the name of this famous scientist who invented the microscope for the first time, and due to his invention the microbiology subject has been evolved and reaches the maximum point. So one cannot deny the presence of this scientist, and his name, I think you know, is Leeuwenhoek. Okay, so now first of all, in today's lecture we divide the slides into few parts: the introduction, the definition, the historical background of microscopy. There are many variables which are used in the microscopy: compound microscope, structure and function, use of microscope, various types of microscopes, and care of microscope. All these are in your syllabus, but in this part we may not able to discuss all the things, but better we discuss the first few points. Okay, so introduction to microscopy. So understanding the optical principle that is actually been taken from physics is very important to understand microscopy, and then it is a construction of microscope. So one can say that although it is a part of biology, but it is not actually a biological subject. It is the core field physics, basically the optics or the light physics. This is actually taken from this. Okay, next. If you take the definition of microscope, then microscope comes from the word micron, means small, and the scopus means aim. So an instrument for viewing objects that are too small to be seen by the naked eye is called microscope. Okay, so microscopy is what? The science of investigating small objects using such an instrument is called microscopy. Right, students? Next. Now, without historical background, one cannot understand it properly. So it has been observed that many scientists on that 18th century tried to not 18th century, before that, tried to make various kinds of microscope of their own. Like Galileo Galilei also invented some microscope. Christian Huygens, one Dutchman, invented microscope, and Hans Janssen also. But the next one. Okay, now you can think about that person which I already told you, the Anton van Leeuwenhoek. In 1661 he discovered the first microscope, and not only that, he bring to notice to the biologist that it is a very intricate tool for studying biology beyond the naked eye level. And on that time he discovered bacteria, free living parasitic microorganism, sperm cell, blood cell, etc. Okay, now you can see the picture of the first microscope that has been used by Leeuwenhoek on that time. It was so simple in looking, but the functional features are very good, and for the concept of that time, it was a nice instrument to be used. And there was a pocket microscope also. That means it can be carried out any place for scientific investigations. Right, student? Next. Okay, now the picture you are looking, this is the most modern picture of a microscope which can be observed in our laboratories and in many research laboratories also. So it is basically a compound microscope with many facilities and many amenities. So nowadays you know that without microscope the world of microbiology is dark actually, and nowadays it is more important. Because if you think about the coronavirus and these other things, this becomes more important. Now come to the topic of magnification. So what is magnification? So magnification is the degree of enlargement, that how an object can be enlarged up to the desired level, and the number of times the length, breadth or diameter any one of this of an object is multiplied. Okay, so magnification is also a part of sharpness also. Now what is resolution? So resolution is a very important function of this. So ability to reveal closely adjacent structural details as separate and distinct. Okay, and next comes the limit of resolution, the minimum distance between two visible bodies at which they can be seen as separate and not in contact with each other. So all this actually dictates how clearly we can observe a particular specimen under the microscope. Okay, next. So out of this, if you think that resolution is more important, because without a good resolution microscope one cannot identify the various parts of a small biological sample. Like suppose for example in a biological cell there are many cell organelles, so whenever you are staining the sample and looking under microscope, then without a good resolution you cannot differentiate between various cell organelles. Okay student, next. So there are other parameters to note it down. First of all, the LR means the already told you that is limit of resolution. Okay, so this depends on wavelength and numerical aperture. And if you look at the various types of microscope that has been developed by scientists so far, then starting from the earlier version to the newer version, there is starting from compound microscope to scanning electron microscope to transmission electron microscope, we are observing that the resolving power is actually decreasing. Whereas for compound microscope it was 200 nanometers, and for scanning same it is 10 nanometer, and for TEM the most important one is only 0.2 nanometers. So you understand that with the increase in technology, resolving power also increases. Thank you.